Contract using the rules of logarithms and express your answer as a single logarithm. Well, let's first of all begin by reviewing the rules of logarithms. The first rule says that the sum of two logarithms is a single logarithm of a product. The second rule of logarithms says that the difference of two logarithms is a single logarithm of a quotient. The third rule of logarithms says a constant multiplied by a single logarithm is equal to the single logarithm of a power. For part A, we have 3 log of k minus 2 log of k plus 3. At first glance, it might appear that we have the difference of two logarithms, but each of those logarithms has a coefficient. So let's first of all use rule number 3 to write each of those as the logarithm of a power. So the first expression will become the logarithm of k cubed, and the second one will become the logarithm of the square of k plus 3. Now that we have the difference of two logarithms, we can apply rule number 2. The difference of two logarithms is a logarithm of a quotient. So we end up with the logarithm of k cubed over the square of k plus 3. For part B, we have minus the logarithm of m plus 5 times the logarithm of 3 plus n. Well, first of all, let's use the commutative property to rewrite this in a different order. Instead of writing it as a sum, we'll write it as a difference. So we have 5 times the logarithm of 3 plus n minus the logarithm of m. Now we can use the same strategy that we used in part A. First of all, we'll use rule number 3 to write 5 logarithm of 3 plus n as the logarithm of the fifth power of 3 plus n. Now that we have a difference of two logarithms, we'll write a single logarithm of a quotient. So we end up with the logarithm of the fifth power of 3 plus n divided by m. For part C, we have 4 log of t plus 1/2 log of t. So first of all, let's apply rule number 3. We'll have the logarithm of t to the 4th plus the logarithm of t to the 1/2 power. Now that we have the logarithm of a sum, we can rewrite that as a single logarithm of a product. So that will give us the logarithm of t to the 4th times t to the 1/2. We have a single logarithm, but we can simplify the argument of the logarithm using the properties of exponents. We have the same base and the operation's multiplication, so we can add the exponents. 4 plus 1/2 is 4.5, or we can write that as 9/2. So we have the logarithm of t to the 9/2. And the meaning of the 9/2 exponents is the square root of t to the 9th power. So our final answer is the logarithm of the square root of t to the 9th power. For part D, we have 1/3 the quantity, the log of x plus 2 times the log of y. Let's start inside the parentheses, and we'll first of all use rule number 3 on the second term. We'll rewrite 2 log of y as the logarithm of y squared. And let's continue working inside the parentheses. We'll rewrite the sum of the two logarithms as a single logarithm of a product. So the log of x plus the log of y squared will become the logarithm of x times y squared. And now we can use rule number 3. We'll take the 1/3 coefficient and we'll write it as an exponent inside of the logarithm. So we have the logarithm of the 1/3 power of x times y squared. But the 1/3 exponent means to take the cube root of an expression, and so our final answer will be the logarithm of the cube root of x times y squared.